Hi, Earth Science class. We're talking about weathering, erosion, and soil today. We've got another video lecture. I missed seeing you guys' faces. I don't really miss you interrupting me though, so this might go pretty fast. I hope you can see my blue mouse. I tried to change it so you can see it a little better. So you have some notes. You have a note page on Google Classroom, and you can, make a split screen and do them at the same time. Pause the video and then fill out the notes, or do it after, whatever your preference is. So these three words get confused a lot. That weathering is breaking rocks down, and erosion is moving them, and deposition later creates soil. So here we go. Weathering is the breaking down of materials, and this happens from the actual weather, from rain and from freezing and from the movement of objects downhill. They continue to break down. And there's two main types. The first is a mechanical weathering, and that means it's physically broken down. So imagine a big rock that then just gets broken down into a smaller and smaller and smaller and smaller rock. That would be mechanical weathering. Chemical weathering is actually going to change what the rock is made out of. And so one example would be like limestone comes from seashells, and that can dissolve in rain. And so there's limestone structures and statues all over the world, and they're getting dissolved. So they're actually changing the composition. That would be chemical. So here's a couple examples of mechanical. These are the two most common. The first is frost wedging. And so as you can imagine, this happens a lot in Montana, in like Glacier Park, where there's little cracks in rock and water seeps into those cracks. And as the water freezes, that ice expands, or ice is bigger than water. So it actually causes the rock to expand, and then it just keeps doing that. And so more water sinks in and expands, and finally it cracks. And so you can find this around your house. You're going to, hopefully, when you do one of the activities this week. And the most common spot is in your road, the potholes. So we don't have a lot of potholes in the summer. Hopefully they got fixed in the spring. But there's tons of potholes right now because all of that water, it finds a little crevice. And when it was winter, it froze and it expanded, and it just broke it until now all of a sudden you have this huge hole. Another one is that this is pressure, an example of pressure. And my kids love this when they're little, finding a sidewalk with a tree root that made this awesome jump. And what's cool, plants are so strong that they can actually push up rock, and not just sidewalks. They can actually break through a huge boulder. And so the pressure from this tree root is actually pushing up the concrete. And I know it's a man-made rock, but that's pressure that is adding pressure and is changing the shape. Okay, here's a common one. I love these rocks when I go fishing, just looking at how smooth they are. You can find these on just about any riverside here near Kalispell. And they're all smooth, and they're smooth because of mechanical weathering. That this rock probably was bigger 100 miles up the river, but when there's a flood and a lot of current, it bounces and bounces and bounces. And every time it bounces, pieces are breaking off of it, and it breaks off and it smooths. And so it's like a natural rock grinder that just continually smooths the rock. And so you notice that some of them have jagged edges, but none of them are jagged all the way. They've all been smoothed by the same force of rolling and pieces flying off of them, basically. And then eventually, as that continues to happen, all rivers lead to the ocean eventually. And so the sand in the ocean is just these big rocks that have been ground down to a tiny piece of sand. This was my son Simon holding some sand from Cabo San Lucas. But they're really cool pieces. They're little chunks of granite. So there's lots of granite in Cabo, and you can see that the granite that you find on the beach as a huge rock is the same granite that's actually sand. And so the same story happens, that this isn't granite, but these big rocks would just keep going down and down and down and becoming smaller and smaller and smoother until they make a sand. And you can see the cool thing about this picture is you can see lots of different sizes. So this is sand. This really fine stuff is silt. And then the clay is the dust. Like, so if you've ever been to a beach and you've just taken sand and dropped it and there's dust flying, that would be clay. So you might want to come back to this when we talk about the sizes of sand, silt, and clay. Okay, the other form of weathering is chemical. And so I said that this is when it's actually dissolved or changed, the rock is changed. And so mostly water does this. And water is really good at dissolving things. And a lot of the rocks, actually, they might be hard, but they're not chemically strong. And so they can be dissolved in water pretty easily. And also, not all rainwater is pure water. Some of it is kind of acidic. So this would be if there is a lot of carbon dioxide. This would typically happen in a river or in the water in the ocean. This would be from like sulfuric gases released from a factory, and this would make acid rain. And so luckily we don't have acid rain in Montana, but they do in some really polluted countries and places on the East Coast. And remember that we tested things with acid. Remember we tested marble and limestone with acid and they fizzed. So you've seen a rock dissolving from a really weak acid. Just vinegar would do that. And so this is called carbonic acid. This can form just from the CO2 in the atmosphere and rainwater, and it can dissolve material. So this is an example showing that all of the gases that come off from factories end up joining water droplets in the air and producing acid rain. And this is an example. So lots of places on the East Coast and the Southeast, they have, old statues. This is a gargoyle that's on a building. And they might be made out of concrete. They might be made out of limestone. They might be made out of marble, but all of those things can be dissolved by rain. And so you can see it was probably a much sharper image before the weather, the rain and the fog and the snow started dissolving pieces of it. This is a really cool thing on a beach in Cabo. And I kind of sat and wondered at it. There's all these boulders. You can see the ocean right there. You can see boulders in the water. These boulders are just sitting on the beach. The sand looks exactly like these boulders because these boulders broke down and made the sand. But you see these really weird shapes, like little holes, little divots, rocks sitting on top. And I just started wondering, is this chemical or is this physical? So what do you think? Do we have evidence that the rock is dissolving? Do we have evidence that it's like physically changed and altered by maybe something else hitting it or smashing against it? Since we have the ocean here, we have during high tide or bad weather, the ocean could get this high. So maybe the ocean water is dissolving it. Maybe the ocean waves hit and then there's rocks in there and they get pounded around and they dig out a big hole. So maybe this big hole here could be dug out by the wave action of water coming up and coming back and all the rocks and the sand kind of digging it out. So there's different rates of weathering depending on where you live. So where do you think, this is part of your notes and I'll let you think about it. Where in the US would you expect most chemical weathering? And remember that to have chemical weathering, you need a lot of water. And where do you think you'd find the most physical? Our two examples of physical so far are mechanical weathering, where the frost wedging and the pressure. So think about where would you find things like that? Okay, so that's weathering. Weathering is breaking down rocks. Once they're broken down, they move somewhere else. And so erosion is the movement of material from wherever it originally was. And deposition is when that material is placed somewhere else. So deposited means to be placed. So we're actually going to save this video for one of your other activities. But that just kind of tells the story of sand, how sand starts from its beginning to the end. And so here's some forces of erosion. I asked you to make a list. And one of the biggest ones, especially in Kalispell, is that water erodes. And so here's kind of a series of events. This looks like a field, maybe in West Valley or Lower Valley. And if they irrigate, then the water has to run off. And so it's going to run down these little channels. And you can see that the water is making that channel. So the water is moving, eroding the sediment. It grabs it and it moves it down, and then it deposits it down here. There's probably some light sediment down there. When that's rill erosion, when that increases, you might get a gully. So a gully would be a really big channel. So you can see that there was some huge flash flood that happened here. And it pulled, this sediment used to exist here, and it grabbed it and it pushed it all the way downhill. And that means it deposited somewhere else. You see some deposition here on the bottom, probably when the water wasn't as strong, but there must be deposition somewhere down here where the water took all the sediment to. So a gully eventually turns into a stream, a creek, and then a stream, and then a river. And this is the Amazon. It's one of the biggest rivers in the world. And you can see that it is moving sediment. That's why it's so brown. So our rivers typically in the summer run clear, and they are moving sediment, but not a lot. But look how much the Amazon moves. You can see just a lot of sand and silt and clay caught up in that water, and it's moving it downstream. And what's kind of cool is you can see the delta. You can see the spot where the river meets the ocean, and it looks muddy. You see this muddy mess coming into a nice blue ocean. So another erosion force is water. This is another picture from Cabo San Lucas. This arch broke recently in the last hurricane, or was it an earthquake? I can't remember. I'll have to look it up. But so the water comes and it crashes, and that's just mechanically breaking it down, and then it erodes it. It moves it deeper into the ocean. And you felt this if you've been at a beach where the waves hit you and they pull it out, and they keep pulling the sand out. And then they push it back in. So it's being eroded, it's being deposited, all kind of in this same kind of cyclical pattern. Another force is glaciers. And so we have some glaciers in Glacier National Park, of course. And what it is a huge chunk of ice. And so the chunk of ice starts up here, and it's moving downhill with gravity, and it's actually moving very, very slowly. And you notice that there are some black lines in here. Do you see those black lines in the glacier? That's pieces of rock. And so you can imagine, you can see it here on the side too, that as the glacier moves, it's grabbing pieces of rock and it's moving it as long as it moves downhill. And then it'll deposit it lower at the end of the glacier. Another source is wind. And so, wind moves sand pretty easily, and we've all seen that at the beach, but it moves it into these dunes. And so it takes it from one spot and it's moving it with the wind. When the wind dies down, it drops the sand. So we have both. We have the erosion as the movement, and we have the deposition in these huge dunes. This is an arch in Arches National Park in Utah. And this is mostly a formation of erosion. And so the wind picks up sand, and it's like a sand blaster, and it blasts holes and other shapes into the sandstone. And so the sand itself is carving this tunnel, and wind runs through here pretty quickly, and it eroded everything that was there. Okay, and lastly, we have organisms that erode. You might see this in your yard in the wintertime, or right after winter. This is a vole, and so voles, they dig through the sediment and they move it around. Here's another example that you might wake up and see a bunch of these tiny little dirt balls in your yard. That's worm poop. So they're moving soil from here and putting it up there. Nice little eroders. And finally, okay, so we have that the weathering, breaking down of rocks, erosion, the movement, depositions, the placement, and now that placement becomes soil. It's the product of that deposition. And so soil is a mix of loose rock as well as rotting material, organic material. So think about, what does Glacier Park look like if you look for soil in the top of Glacier Park? If you've been there, it's pretty rocky. And if you look down in Lower Valley, or probably in most of your yards, you have kind of a nice fertile soil. It takes a while to get to some rocks. So we have two types. We have a residual soil. That would be what you find in Glacier Park, where it's mostly rocky with a little bit of dirt. And a transported soil is what you'd find here in Kalispell or Lower Valley or Evergreen, where you have some organic material, you have some really fine sand and silt sediments that came from a river. And so transported soil is usually kind of nicer soil to grow things in. Now, when we look at soil, there's kind of three components that we talk about: sand, silt, and clay. Remember, I showed you that picture of Simon holding some sand. The sand is the typical size that we think of. The silt is really, really fine stuff, the stuff that kind of sticks between your toes and like is really hard to get off when you've been at the beach. And clay is more like dust or mud. And if you look at this, these are the horizons of soil. So bedrock, this would be what's showing at Glacier Park. So in Glacier Park, you have mostly bedrock and you have a little bit of weathered rock fragments. Where we live, we probably have all of this. We have the humus, which is organic material, and we have the more rotten humus, and we have some other less kind of worn down sand and silt and clay. So this would be the residual soil. This is transported soil. Okay, that's it for the day. Take a look at those notes and make sure you turn them in, and I hope you have a good day.